Okay, hi students. Welcome back. Today we'll be doing the last topic of this chapter, that is molecular mass, and we'll try solving some numericals related to that. So this chapter, atoms and molecules, will be ending soon, and then we'll be beginning with a new chapter. Okay, so why exactly molecular mass matters? Okay, why is it important? Why we are trying to figure it out? So first of all, it helps in the stoichiochemistry. If you remember, I told you about stoichiochemistry, right? Stoichiochemistry is the amount of reactant, used to form some amount of product. So how much product is being formed? How much do we need? Right, for all those industrial purposes and all. So molecular mass is important. Then only we will be able to figure out what exactly the mass of the compound is. Now, for understanding the quantities, so it also helps us understand the amount of substance present. Okay, in any kind of uh, substances, if you are looking at, or in any kind of matter, if you want to look in depth at what exactly the amount of matter is present, how much, so that you can figure out by knowing the molecular mass of the kind of matters present in them, like for kind of example, the kind of elements present in them. And the foundation of chemistry, basically many areas of chemistry, pharmaceutical industries, or any material science, all these need molecular mass to do further calculations. Okay, so now, what exactly? Okay, ignore this image again. This is not the correct representation of anything. This is just for the uh, show, you can say. Okay, so what is molecular mass? Molecular mass is the sum of atomic masses of all the atoms present in a molecule. Okay, it is expressed in atomic mass units. Its unit will be U. So for example, the molecular mass for, let's say, water. Okay. So there are two atoms of hydrogen are there, right? So we will take the atomic mass of hydrogen, that is 1. We'll multiply it by 2. But then we have to get the atomic mass of water, right? Or molecular mass of the water, to be precise. So molecular mass of this water, one molecule of water is there, hydrogen is there. The mass of hydrogen is 1. How many hydrogen are there? 2. So it will be 1 into 2 plus, what is the mass of oxygen? It's 16, and hence we'll get 18U. 18 atomic mass units. And that will be the mass of our molecular mass of our water. Okay, clear? Right. Okay, moving ahead. Okay, atomic mass table, if you can look at. So what exactly the atomic masses are. So these are the particular, masses you will be dealing with. For hydrogen, it's 1, easy to remember. For carbon, it's 12. You'll be using it a lot. For nitrogen, it is 14. Oxygen, it's 16. Most of the times you will see the atomic number, okay? If you can recall the atomic number of any element, the molecular mass would be double of it. Molecular or atomic mass. Molecular will be the complete compounder element. Atomic mass will be double of that atomic number. Sometimes it can differ. For example, let's say oxygen. So atomic number of oxygen is 8, if you can recall and remember from previous classes. So the mass would be 8 into 2. That is 16. Okay. Similarly, for example, for let's say calcium. So the atomic number of calcium is, it's easy, it's 20. Okay, so the double of 20 would be 40, and that is the atomic mass of calcium. For some elements, it could be different, and you'll have to remember. For example, in chlorine, it is 35.5. So this is a little bit different. Then for sodium also, it's 23. So that is something you have to remember. For aluminium, it's 27. So all these masses, if you can remember, you'll be easily able to solve the calculations. So for example, molecular mass of carbon dioxide. Okay, so here you write down how many atoms are used to make this whole molecule. For carbon, 1 atom is used. For oxygen, 2 atoms are used. So carbon, mass of carbon is 12U, right? And mass of oxygen is how much? It's 16, right? 16U. Now, since 2 oxygen atoms are involved, so 16 into 2, that is 32U. Now we will combine this and this together. Okay. Now once you'll add this, you will get 44U. So the molecular mass of CO2 or carbon dioxide would be 44. So I think you'll be able to solve a lot of questions if you can just remember or recall the atomic masses of each element, or not each element, the elements which are of use. And if it is given to you in the question, that is very well, then you can easily solve it. Okay, so let's try another example. So here, for example, we have taken calcium hydroxide. Okay, now calcium hydroxide, if I ask you a question, what is the valency of hydroxide? Can you tell me that? Try answering that question. Okay, also count the atoms of each element, the next step. Okay, so you will count the how many atoms are there. So for example, for calcium it's only one atom. For oxygen it's one, but also two times, right? So 1 into 2 already. And for hydrogen it's 1 into 2. So total two atoms each. Atoms. Okay, atoms. 2 atoms. I'll write 2 here. Okay, 2 atoms, and 1 atom. Now you'll add the masses accordingly. So for calcium, we know the mass is 40 U, plus oxygen, the mass is 16 for one oxygen. But here 2 atoms of oxygen. So 16 into 2, right? Let's not write U here. It will be confusing. Let me just erase it. Okay. And coming to hydrogen, the mass of hydrogen is 1 into 2. And then you will get here, this will be around 32U. This will be around 40U plus 2U. If you sum it up all, you will get 4 here. And this is a 7. 74U would be the mass of whole calcium hydroxide. This complete would be one molecule of calcium hydroxide would be 74U. Okay, I hope that's clear. Again, this is not a good image of depiction of what we were dealing with. This formula is correct, but this is irrelevant. Okay. Now, molecular mass of ammonium sulfate. So, ammonium sulfate, you can try solving this question. Okay, you can try solving and come up with a conclusion, and then answer should come 132. That is 132U. Okay, atomic mass unit. So, just figure out and let me know what methods you have followed. Now, just few more problems. So one I'm going to solve and one you can solve. So I will solve the easy one because again, difficult one you should be able to solve without my help. Okay, so let's take this, compound. So this compound is called as ethane. Okay, it has 2 carbons attached to it. So it is something like this and this. The structure is like this. Hydrogen, 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 and hydrogen. Okay, so how many atoms of carbon are there? That is 2, right? 2 atoms. And also, how many, what is the mass of one carbon? That is 12. So 2 into 12 would be 24U. So total mass of carbon here in this whole compound is 24U. Now we'll try to figure out the mass of hydrogen. So it is, how many atoms are there? 6 atoms, right? 1, 2, 3, 4, 5, 6. I'm pretty sure that you are able to figure out what is atom, what is molecule, right? So 6 into, what is the mass of hydrogen? That is 1. So that is 6 only, right? 6U. Now once you add these two, what you'll get? You'll get 30U. Now for aluminum sulfate, you will try to solve this question. Okay, try solving for aluminum sulfate. Now, you can, take sulfur alone and oxygen alone, but do consider this 4 and 3 and try solving, okay? Okay. And then again, we have few questions which you can try for yourself and let me know if you have any trouble in that. So the question 1 is molecular mass of water would be, that would be 16U, 18U, or 20U. I think this is clear. This should stay in your head because it's very easy one. Molecular mass of Na2CO3. Okay, so this you have to find out. I have already given you the calculations and everything. So you just have to put it and then solve it. Even like the answer is kind of clear there, written there. Okay, I have forgotten to, take off the answer. So just, it's fine. Now, the molecular mass of CH4 is 14U, 16U, or 18U. So that you have to figure out by yourself. Now we are done with this chapter. Thank you so much for watching. Find me on Urban Pro for any doubts or queries. Okay, see you soon. Take care. Bye bye.